This is the 2.2D lesson. We're going to examine slope in a context. Basically, going to cycle back to some of the things we did earlier in the module. Number 1 says the context is Peyton goes to Yum Yum factory to buy jelly beans for her friend Molly. At the factory, Peyton notices that 2 pounds of jelly beans cost $9. We're going to state the independent, dependent variables and fill out a table and also fill out a graph. In order to maybe identify the independent, dependent, we're also going to maybe fill in the table and think about these things. And it doesn't have 0, so I'm going to include 0. We usually like to have 0 there. So we're going to think about what are we saying is 0, 1, 2, 3, 4. It's probably not the cost. In fact, I think the y is the cost or the money. And it says 2 pounds of jelly beans cost $9. So this is probably this. So this is pounds. Right, the total amount of jelly beans, which they're determining or weighing in pounds. So this is 0, 0, 0, because 0 pounds costs $0. So it actually looks like this one's going to be proportional. 1 pound is going to cost 4.5. Remember, one of the ways that we figured that out was we would do our y over x ratio like this, and that all of these, should be equal to 4.5. All right, and once we know our y over x ratio, and that's proportional, we know that this is it's gonna keep going up by 4.5. So we have 13.5, and then we have 18. If we were to divide these out, which we don't necessarily need to do, we would see that they're all equal to 4.5. All right, so we now know that the independent, or the x, is number of pounds, and the dependent is the total cost. We filled out our table. All right, now we're going to fill in our graph. This is number of pounds, and this is total cost. As we start to graph this, so 0, 0, 1, 4.5, 2 is 18. We also need to think about whether this is going to be discrete or continuous. Oops, actually it's 2, 9, right? So can we have fractional parts of pounds? And we can. And can we have fractional parts of cost? And we can. So this is going to be continuous then. And we might even skip to 4, 18. All right. Try to draw on my line here. All right, there's our graph. It says D, why is the graph only in the first quadrant, or quadrant 1? Why is nothing negative? You cannot have negative pounds or negative money. Well, you can sort of have negative money, but as far as going to buy jelly beans at a store, it wouldn't make sense to have negative pounds or negative money for that. E, we're going to state the slope. So the slope would be our rise over run here on our graph, or if we go into our table, our rise over run in our table, which was up 4.5 for our y and up 1 for our x. So the slope was 4.5. Feel free to pause the video if you need to go back and see what I just marked up in the table. All right, and the slope represents that it costs $4.50 per pound of jelly beans. Y-intercept, where does the graph cross the y-axis? We'll maybe even highlight it. There it is. And 0, 0 does count as a y-intercept. And so 0 pounds costs $0. What does it represent in the context? What is 0, 0? So 0 was, the first 0 was number of pounds, and the second 0 was the total cost. Next, we're going to write an equation. So if it's proportional, it's going to be y equals blank x, versus non-proportional was y equals blank x plus something else. And the value here is our COP, or our rate of change, which is 4.5. We've already defined the variables, by the way, so we're not going to do that. Next, Molly has $15 and y was money, so we're going to set this equal to our y value, and we're going to solve for x. We're going to pick the opposite of multiplying by 4.5, which is dividing by 4.5. And we get x equal, divided in the calculator, comes out to be 3 1/3 pounds, or 3.3 repeating. Last, we're going to rewrite it so we have a non-proportional relationship. And it also asks for our equation. So maybe we'll just start with our equation. Let's say we have an equation of y equals 4.5x plus something, but it can't be plus 0, otherwise it goes away. How about plus 2? Let's say it costs $2 for a cup to hold the jelly beans, and $4.50 per pound. Sometimes when you go to a place, they might charge you like a flat fee, an entrance fee, or an initial amount. So that way, if you don't buy much, they still get some money. Sometimes when you go to like a frozen yogurt place, they might have an initial amount for just the cup and the spoon, and to kind of set everything up. All right, so we rewrote the situation so it's non-proportional. So there's an initial amount, so 0 pounds costs $2. And we wrote our equation and described our new context.